Okay, so starting at the top, we're just doing the ratios today. We aren't plugging anything into the calculator, but what today we're doing is working on the setup, so that way when we do plug it into the calculator, we get the right answers. So the word trigonometry comes from two Greek terms, trigon meaning triangle, and metron meaning measure. So trigon meaning triangle, and metron meaning measure. And then a trigonometric ratio is a ratio of lengths of two sides of specifically a right triangle. So this only works with right triangles, so keep that in mind. Okay, so relationships between sides and angles of triangles. So here's where we start building the vocabulary. First of all, on all these triangles, you'll have like a designated angle. You'll have a right angle, of course, because it is a right triangle, and you have to have a right triangle for this. But then you'll have another designated angle. This symbol right here is called theta, and theta refers to our designated angle. So this is a theta, and that's the designated angle that we're going to be focusing on solving for when we get there. But okay. Based on this angle, the first thing that you would label is the opposite side. So opposite this theta, or designated angle, is the opposite side. That would be this side right here. And a lot of times we'll abbreviate it as just O. Okay. Then right here, this is the hypotenuse. Hypotenuse is the longest side, and it is opposite the right triangle. So this is your hypotenuse, and the abbreviation for this is H. And then last but not least, the last one that you would label is actually adjacent. The word adjacent means right next to. So it's adjacent to this theta symbol, or the designated angle. Something that confuses people sometimes is like you have adjacent, which means right next to. Are they talking about this side or this side? Because to me, both of those are adjacent. Yes, they're both right next to theta, but one of them will always be hypotenuse, and hypotenuse is the longest side. So the longest side is hypotenuse, and then whatever's left over is your adjacent side. Okay, now moving on. Now applying it over here. Complete the following based off the corresponding triangle below. So we have our triangle here. We have our theta, so this is our designated angle right here. And it says which side is the hypotenuse, which leg is opposite, and which leg is adjacent to theta. Okay, well, opposite theta would be right here, opposite. Then the hypotenuse would be opposite that 90-degree angle in the longest side, so this would be hypotenuse. And then last but not least, we have the adjacent side right here. Okay, so which side is the hypotenuse? That would be AC. Which leg is opposite theta? That would be segment BC. And then adjacent to theta would be AB. Okay, so now try it on your own over here. Which side is hypotenuse, opposite, and adjacent? So try it on your own. Try to fill in these segments here. Okay, so here is my answers. Compare them to yours. Make sure that you got the same thing. You guys good? Okay. Ready to move on to the next page? Or not? Some people are still writing. Next. Or no? No? Yeah, okay. Okay, next. Okay, so here we're going to bring in SOHCAHTOA, which I'm sure you remember from geometry. Everybody remember? Yeah, so I'm sure you, like, it sounds familiar. If you need it re-explained, I'm going to re-explain it here, so we're good. So, actually, I'm not going to start at the top. I'm going to start with this, like, POW symbol here. This is where we put SOHCAHTOA. So, we have SOHCAHTOA, and I'll write out what these stand for. SOHCAHTOA, and this was the acronym to help you remember the trig ratios. And so to this day, I still write this out anytime I'm doing trigonometry, so I can use it as a reference. So SOH stands for sine equals opposite over hypotenuse. CAH, or CAH, is cosine equals adjacent over hypotenuse. And then TOA, TOA, stands for tangent equals opposite over adjacent. Okay, and then moving up to the chart above. Okay, so trigonometry. And here I actually wrote out the whole word, which is nice. This says sine. Sine equals, I'll use color, opposite over hypotenuse. And so literally as I'm doing it, I'm still thinking in my head, SOHCAHTOA. So just writing it wherever you're working can really help you just reference it. And then sine is actually spelled out like this, but in the calculator we see it abbreviated SIN. But we still say sine, not sin. Okay, and then cosine over here, the abbreviation is COS, so on the calculator you see that as the abbreviation, and cosine is adjacent over hypotenuse. And then tangent, which is abbreviated tan on the calculator, is opposite over adjacent. Now we're going to practice identifying the ratios just with letters. It says sine of A, so that is our designated angle or our theta, so I'm just making a mark there. And as I'm doing A, I'm actually going to do sine of A, cosine of A, tangent of A, and then I'm going to erase all my marks and do sine of B, cosine of B, tangent of B, just FYI. That's why I'm working in pencil again. So from this angle, this designated angle, our opposite side is right here. This would be our hypotenuse, and then adjacent is right here. So by labeling it, it makes the rest come together a little bit easier. So sine of A is opposite over hypotenuse, so that is opposite over hypotenuse, A over C. Today all we're doing is setting up the ratios. Then cosine of A, cosine is adjacent over hypotenuse. So adjacent over hypotenuse, which would be B over C. Then tan of A, opposite, and I'm literally opposite over adjacent. So opposite over adjacent would be A over B. Next step, I'm erasing these marks now because now our designated angle is a different angle and it's going to change some of these. Okay, so now we're going to look for sine of B, cosine of B, and tangent of B. So my designated angle now is on B. And I'm going to relabel everything. So my opposite side is now over here. hypotenuse will still be in the same spot, and then adjacent is now over here. And then sine of b, opposite over adjacent, opposite over hypotenuse. Sorry. Opposite over hypotenuse would be b over c. Cosine of b, adjacent over hypotenuse, a over c. And then tangent, which is opposite over adjacent, b over a. Now we're bringing in numbers for the next part. Okay, so how do we use these ratios? Now we're going to do the same thing we just did using numbers. They give us number sides. We have our designated angle, theta. Based on that, you would label your sides. So go ahead and label them opposite, hypotenuse, adjacent. See if you get it right. So this would be opposite, hypotenuse, adjacent. Is that what you got? Cool. Okay, so now based on that, we can fill this in. Sine, again, you might even want to write this out again. SOHCAHTOA. Opposite over hypotenuse would be 3 over 5. Adjacent over hypotenuse, 4 over 5. And opposite over adjacent, 3 over 4. Cool. Okay. Next. Okay, now we're going to continue practicing this. Write each ratio as a fraction in simplest form. So when we get our ratio, we may have to simplify it based on the numbers. Sine of theta, cosine of theta, tangent of theta. So we're working with the same angle each time. This is our theta, our designated angle. Then we have our opposite side, hypotenuse, and adjacent. And then we can just write out the ratios and simplify as needed. For this one, you may have already done it, but here is theta, opposite, hypotenuse, adjacent. It comes out like that. This is coming back to easier than it felt. Then at the bottom portion here, yeah, Eric also heard that Miss Knight used the same exact template. Yeah. Did Miss Bueso too? Because these are Miss Bueso's notes. Does Miss Bueso use this or something different? Okay, so this last section here, it says use triangle ABC to express each ratio as a fraction. Remember to simplify. So for this, they're using different designated angles. So what I would do is, again, I'm using pencil so I can erase, but I'm going to do all the A ones first because I can like mark it up. So here's our designated angle A, and then we have opposite, hypotenuse, adjacent. And then I can find the ratios for all the ones that are A, and again, I'm using SOHCAHTOA and literally writing this down as a reference as I do these. So sine of A, opposite over hypotenuse, so that would be 16 over 20, which would simplify to 4/5. Then cosine of A, adjacent over hypotenuse, 12 over 20. And tan of A, opposite over adjacent, 16 over 12. sine of C. I'm going to erase my marks and then label everything based on angle C now. So we have angle C right here. Opposite. Hypotenuse is still here, and then adjacent. Then on the next page, there is a practice page. If you have the notes printed, if you don't, I'll tell you what to do as well. There is a practice page where we're just practicing the ratios. So I'll show you how to set this up on a piece of paper. If you're doing it on a piece of paper, just number 1 through 24 because there's 24 of them. And so, let's see. So if you're doing it on a piece of paper, let me show you how to set it up. So 1, sine of A, 2, cosine of A, 3, tangent of A. So I'm setting it up as if I'm doing it on a piece of paper and not on the worksheet. If you have the worksheet, awesome. But I think most of you don't have it. So once you have that, and again, you'd have 1 through 24. So for this set of 3 problems here, you have a triangle that looks like this, and it's 13 by 5 by 12. This is A, B, C. So you write down the triangle. The designated angle is angle A, so just make a mark there. And then you have your opposite, hypotenuse, and adjacent. And then you can write down the ratio. So sine of A, and again, on your paper, you're just going to need to write down SOHCAHTOA so you can use it as a reference point. Sine is opposite over hypotenuse, so 5 over 13. And then cosine of A, adjacent over hypotenuse, so that would be 12 over 13. And tangent, opposite over adjacent, would be 5 over 12, like that. So if you're doing it on a piece of paper, just do it like this. It shouldn't take very long. So 4, 5, 6, you'd write down sine of B, cosine of B, tangent of B, and then just sketch out the triangle. 5, 13, 12, and this is A, B, C. And angle B is right here. So this would be opposite, hypotenuse, and adjacent, and then you fill in the ratios. If you're doing it on the worksheet, same idea. You designate your angle, sine A, cosine and tangent and A. It's all based on A. So you can label opposite, hypotenuse, adjacent, and then fill in your ratios. 5 over 13. Cosine of A would be... Can you just write the letter next to it, or do you have to... Write the ratio, please. SOHCAHTOA. Then cosine of A would be 12 over 13. And tangent, 5 over 12. Okay, so wherever you are. Okay, so I will leave this up here. So if you're doing it on paper, you have a template here. If you're doing it on the worksheet, this is what I'm looking for there. I'm actually going to walk around and grade this by the end of class, so just do it now, practice it. If you have questions, let me know. And then when everybody's done, I'll walk around and give you credit for it.
Wait,
If you...
Are we doing all of them? Like all 8? Or just the 4?
What do you mean all?
Are we doing the other side?
Yes, you're doing the other side. So once yeah, most of us are done with this side, I'll just show the other side. Okay, and then once everybody's almost done, I'll go around and give you credit for this as well.